Okay, we're going to finish up today with a discussion on queues. And well, this is going to be great, because once we finish queues, we can go on to our next project. So queue, a little louder, please. No, that was the wrong sound. That should be, yeah!
Yeah, you're right.
All right, so a stack was last in, first out. Last in, first out. So this one, they're going to change it up a bit. It's going to be first in, first out. Just like when you go in line, it's going to be the same thing. So example, waiting in line in a bank, waiting in line everywhere, it's called a queue. Well, we call it a queue because that's, you know, out of all the Americanness, you'd think we would have used the word line here, but we used queue.
The computer calls it a queue.
Yes.
Yeah, oh, we throw it into the queue? Yeah, that's because that's what we called it from the beginning. We didn't throw it in the line, which is,
Just line. I got to put it in.
I mean, no, this is a good thing because it is a queue. It's just, you know, finally we accepted something. All right, we're going to, hey, look, it's going to look the exact same. Initialize the queue. Is it empty? Is it full? The front, the back. We can get what's in the back and the front. And we can add from the queue and delete from the queue. Okay. Oh, wait, do all those make sense? Make the queue 0, ask if it's empty, ask if it's full, figure out who's on the front, or aka the head, who's in the back, aka the tail, and add to the queue. Where does it get added? To the back, and then delete from the queue from the front. Right. Okay. Oh, yeah, so what do we need to keep track of?
Head and tail.
Head, tail, and, okay, they're using an array. Oh, should we use an array or a linked list? Or a stack?
Linked list. Doubly linked list.
Doubly linked list.
Yeah.
Why would?
Why not?
Why not?
Yeah.
Why is it actually a good idea?
Because you can go back to and forward.
Yeah. Well, right.
So you can keep track of it. And if someone in the middle wants to leave, maybe they're like, I want to.
I'm done with this. No.
No.
This is a queue.
Yeah.
No one leaves the queue.
Well. maybe-
All right, so they're using an array, which is not how I would do it. Add an element to the queue. So oh yeah, this actually gets even more confusing. Oh, maybe we will do this. This is fun. Oh, this is fun. So you add to the queue the A. All right. So we add A. All right. So queue front, we're going to position to the next. All right, that sounds great. So we have A, B, C. Notice that the rear is C and the front is A, because A is still waiting at the front of the queue, right? And then we added B, C. C is up the rear or the tail. And you still have some empty stuff in the array. All right, that's cute. All of a sudden, A decides to finally get out of the queue because it's its turn. So you increment the front by 1. Ooh. Does anyone see? You increment the front by 1. Okay.
Move everything over?
No.
No, because you're starting at the front.
Yeah, I mean, we could do that. That might be your implementation, which actually would
No.
make things a little easy. Will the queue design work? Well, what if A represents adding and D is deleting? So A, D, okay, that's a lot.
Yeah.
Well, all of a sudden we're in the back where the queue front, notice we kept adding and deleting and we're going down this array. And then at the end, our queue front's at 97, the queue rear is at 99. What happens when we want to add something?
You think it's full?
No, the queue's not full. The array's not full. You still have
It's
open
not full.
spaces.
But how can you add to it? Because you have to add from the back.
Right. So where's the back now?
Almost at the end of
No, it is at the end of the array. We want to add something to the end of the queue. Where do we add it? We still have room in the array. Huh?
Add it to the front.
Yeah, so if we add something here, it goes back over the front. Everyone ready to code this?
Sure.
So it's added to the front of the array. So what does that mean, the queue tail or rear is going to be. Wow, it doesn't tell you. So if we add another element and it goes over here, what is Q rear or Q tail going to be equal to?
0.
So the front is 97 and the end is 0. Yes.
So it reversed it?
No. You start at 97, you just go to the next, and then you jump over to the end. So this is what they like to call a circular queue. And oh, here's another picture, 98, 99, and then the end or the tail goes back to the beginning after adding Z. Okay?
Wouldn't it just be easier to use a linked list? Right? If we're going to this.
Way easier, yes. Well, we're going to look at the array and realize why we don't do it this way.
You gotta learn the wrong way to appreciate the right way.
Did I make you do this last semester?
I think so.
Oh, I did.
I don't think you made us like implement that.
Oh, okay. But
But I think you did teach us this.
Yeah, I don't know if there's a certain level of evilness that's nice about making you.
No, let's
So what if we want to delete one element?
You have to
That's just very
resize.
annoying.
You have to find it, resize the whole thing, don't you?
No, if we want to delete X, don't we just increment the front by 1? Yeah, because the front of the array, he's out, so we'll increment the front of the array, right? I mean, that's what we did earlier. You're just giving me a funny look because that array looks funny. See, look, we had A, B, C. The front was at 0. The end was at 2. We decrement, so A gets removed from the queue. Now the front's pointing to B and the end's pointing to C, right? That makes sense. You're just looking at me funny because if the queue only has one element, if you decrement, you just move the front over, the front's now 99 and the end is 98, right? So I have a question for you. How do you know if the queue is full or empty at this point? Because what if it was full, then your front would be 99 and the tail would be 98 because it went all the way around.
You have to check and see if there's anything in them.
Well, I mean, we're not deleting the elements in there, we're just moving the pointers over, or the indexes over.
Keep track of size.
Keep track of the size is going to be the easiest way to do this. Right, so that's what the deletion case I just told you. What if the whole thing is full and then now you got to update the variables. All right, so if the whole thing's full and you want to decrement 9, or I'm sorry, Z, then yeah, the front would go to 98 and the rear would still stay at 90. Wait, what happened here? Why is the front still at 99?
Shouldn't the front be 98?
No, the front should. This is adding something. So it added the Z. Oh yeah, there. Add Q, Z. Perfect. All right. Why is it called deleting when you add it? All right. Ignore that slide. We're not going to talk about that. Solution 1: keep a count, which is what Malik says, and let me tell you, that's what you need to do. Please don't do it any other way. All right. They're going to go talk about the code. We don't care about that right now, because when it comes down to it, doing a circular array in order to implement a queue is just silly. Although it does consume less memory. Because a pointer does consume memory. Every time you use a pointer, it consumes, well, nowadays 8 bytes actually. While an array just had the whole array of values. Although actually the array is wasteful because then you have empty spaces, so the array would take up more memory, depending on the situation. Yeah. All right. The array size is fixed, only a finite number of queue elements. The array requires things to be treated in a special way with the queue front and queue rear. Wow, that was complicated and annoying. So a linked implementation simplifies many issues. It's never full because memory is allocated dynamically. So really, it's only full once you can't allocate any more memory. And you only need 2 pointers, namely the front and the back. Oh, that's nice. And then, are you going to have this situation where you have, the front and the back, cross like they did before? Why not?
Because you can just keep adding.
Because you can keep adding. There's no circularness going on. Circular silliness. All right, if the front is null, then obviously your queue is empty. The queue is never full, so is full is always false. So you only provide it because it's part of the implementation that was described.
So we can literally just write return false.
Yes.
Okay. I was just asking.
Yes, literally, that's all we have to do. All right, initialize it. Well, if you're going to initialize this queue, what are you actually initializing? Don't read the slide because it's going to throw you under the bus. What do we do with the stack? Question. When we initialized it, aka we constructed it, what did we do?
Use the linked list.
We constructed a linked list. That was it.
Okay.
That was the initialization. So we want to add to it. What will we use to add to it?
Oh, you say to like the stack, like what we did for stack?
No, for queue. We're at a queue right now.
Yeah.
And we want to add to it. What do we do?
Just add to the end.
Add to the end. Yeah. Okay. Perfect. And then the front operation, we just
Add to the front.
Or, wait.
getting the first element.
Oh, you then pop it.
We're not popping. We're just getting front. Front is basically get the front or get the top, get the first element. So
Oh,
you
okay.
just return what's in the front. And you can do the same thing with back, so now you have back. And then deleting, and that's what you're talking about where we would
Pop it.
pop the front. Yeah. Or we would delete the front, which would just move the head pointer down. All right, this is actually, hopefully we've talked about that.
All of this is done on templates, isn't it?
Yes. Oh yeah, everything will be templated now. So be ready for that. You ready for that, Jonah? By the way, your projects are not, well, are they templated? Was the last one templated? No. Last project was not templated. I don't think your projects are going to be that templated. The next one won't be. Your third one will be. All right. Where are queues used? Real quickly, queues are used a lot in simulations. If you want to add a bunch of objects and you're simulating a bunch of objects, you want to evaluate them in a certain order, so it's usually in some type of queue. Or you can actually do a queuing system where, study the behavior of certain real systems by putting them in a queue and evaluating them in order. All right. Wow. So that's all we're going to say about queues. We're going to get to more into queues in the future. Well, yeah, we'll just say that. So the summary, the extendo summary, stack, last in, first out, what does that mean?
Put it on. Pop it on.
Yeah, so it's like when you stack stuff, you take off the last thing.
Yeah, you take off the last thing that was put on.
Yeah.
Can be implemented with an array or a linked list. Middle initial should not, or middle element should not be accessed to replace postfix notifications. Operators written after the operands. Key thing I wanted to make sure I mentioned is that the stack was used a lot because it was a simple data structure. In old computers, you did not have much hardware, so if you only had to keep track of one pointer, namely what's on top of the stack, that was a very good thing to use and something you could actually implement. So that's why stacks were used so much back in the day, and actually today they're still used. And then a queue acts like a queue that we're thinking of. We're talking about simulations, but you also have your queue when you're printing to a printer as well, keeping track of your different jobs, then you reprint it off in order. It's a restricted version of array and a linked list. Which of those two should you use for your queue? So you can use an array. Good luck. I mean, have fun. You can.
You can.
Oh, I can totally do it.
I can also jump off this balcony.
Whoa. Careful there. Don't start talking about things like that. We have to report you.
Technically, I can.
Look, I'm recording, Joan. All right. Any other questions? because that's going to be it, and I'm going to be done just in time for lap time.